I'm Kristen Kettering.
And I'm Randy Kinnitz.
And this experiment is called Dragon's Breath, or the combustion of ethanol.
For today's experiment, you're going to need 2 spray bottles, 2 storage containers, and a candle taped to the end of a meter stick.
You're also going to need matches to light the fire, a container of copper 2 chloride, a container of lithium chloride and copper 2 chloride, and also the final solutions that we've already mixed. And even though these solutions are already mixed, what you need is 50 milliliters of ethanol in each solution, 7.5 milliliters of distilled water for each solution, and 1.5 grams of lithium chloride and 1.5 grams of copper 2 chloride. And then you combine all of it in a beaker and then pour it all in the spray bottle. And once you pour it in the spray bottle, you need to use the matches to light your candlestick. Just make sure you don't burn yourself, because that would kind of ruin your day, you know. Okay. And then the first trial of the experiment that we're going to do is going to be with the lithium chloride. See? Dragon's breath. And the candle going out. And then as you can see, the flame turned a dark red. And this is caused because of the lithium chloride solution.
Alright, next you're going to grab your meter stick and get the copper 2 chloride solution. Blew out again. As you can see, it was a blue flame. It's a same reaction, just a variant of the experiment, so that's why you get the different color, because of the copper 2 chloride.
And then as you can see, the results are very obvious. You got the really pretty colored flame. And this happens because ethanol is it ignites. And this happens because ethanol is combustible, and when the solution is dispersed onto the flame, it ignites it. And the compound is dissolved into the ethanol and water, and when the lithium chloride solution is sprayed on the flame, it turns a deep red color. And as the copper 2 chloride solution is dispersed on the flame, it turns the greenish blue.
The lowest energy state of an atom is called in its most stable state, it is its ground state. When an atom is in its ground state, it needs the energy from the heat to excite the electrons and then transform into a higher energy state, which is called its excited state. The electrons in its excited state subsequently give up their energy, and when they come down and they release that energy, that's when it releases the light that we can see. For a more detailed description of this process, you can look in the Chemistry Principles and Practice textbook.
And then the chemical equation for the combustion of ethanol is ethanol plus oxygen yields copper dioxide and water. And as you can see, none of the additives that we added, which would be the lithium chloride and the copper 2 chloride, cannot be seen here because they're additives that make the color. And as Randy said earlier, the color comes from the electrons going into their excited state. And when they jump from their excited state back down to the ground state, that's when the color is released.
Electrons in their excited state want to give up their energy to return to the ground state. When electrons give up this energy, that's the light that you can see, as you just saw in the experiment. According to ScienceDaily.com, ethanol can also be used in internal combustion engines. It can either be used alone or along with other different fuel types, such as gasoline. It has been recognized for its possible long-term economical and environmental impacts that it can have over fossil fuels. It can be combined with gas in any concentration all the way up to full ethanol. And as you can see, here is the combustion reaction that would occur inside of the engine. Ethanol without water, which is anhydrous ethanol, can be mixed with gasoline and the use of petroleum fuels as well to reduce air pollution.
And then another way that combustion can be used, according to the EPA's website, is in getting rid of medical waste. Medical waste such as bodily fluids that are just left and stuff removed in surgery are incinerated. And they are incinerated because you can't just have things like that just laying around or thrown away. And they're incinerated because of the fear of contamination and air pollution. And this is why combustion is used. And then these are the references that we used in our experiment.
Here's our equation of combustion of ethanol.
And I hope you guys enjoyed it.
Thank you.